In this video, we're going to talk about annuities, and we're going to look at the annuity equation and then do a couple of examples using that equation. And so we're going to start by talking about what an annuity is. And let's go back and think about what we learned in the compound interest video, which is the last video I made. And we looked at the compound interest formula, which is right up here. And in that formula, we saw that this formula is valuable if we make a one-time deposit. We call this our principal, and we have a certain time period that we're going to keep that money in the account, and a number of times it's compounded per year, so that's the N. And then this can calculate how much money that one-time deposit or our principal can earn over time, and that gives us the future value, or A, the amount of money that you have in the end. So an annuity is similar because you do, make deposits, and that money grows, earning compound interest. So that's nice. You're still taking advantage of that compound interest. But the nice thing about an annuity is it's a savings investment where regular deposits are made into an account rather than a one-time deposit. And so those deposits could be every month, it could be every year, quarter, etc. But it allows people who don't have, this large sum of money to deposit at one time, which is, let's face it, most of us. It allows people to save money using compound interest, but making deposits, maybe even deposits that come out of the paycheck. So it makes it a little bit easier to save. And R in our formula, because we no longer are going to have a principal because we're making these regular payments instead of this one-time deposit. So we're going to use R in the formula to stand for our regular deposit. So it's going to represent the amount of the regular deposit. And for our purposes, the frequency of the deposit is going to match N. So that typically N stands for the number of compounding periods for interest per year. Every time the deposit's made, that sort of stands for, a period of, that's when that interest is compounded. So for example, if we make 12 deposits per year, so that would be every month. If somebody makes a monthly deposit, we're just going to use N equals 12 for the formula, because that would be equivalent to that interest being compounded 12 times a year. So in summary, compound interest, we have one deposit, and we call that P our principal. With an annuity, you can assume that there are many regular deposits, and we call those regular deposits R. Okay, so now we're going to jump into our first example, and we're going to do two examples, and in each of these examples we're going to use the annuity formula, but we're going to use a different type of the formula in each one, so you can see basically all the different types of annuity problems. And so right here you can see they appear to be two different annuity formulas. They're really the exact same formula, it's just they're solved for different variables. And so you'll notice in this first equation it's solved for A, which represents future value, so the amount you're going to have in the end. Okay. In the second one, it's solved for R, or your regular payment. And so you're going to have to pick which one to use depending on what the problem asks for. So if the problem gives you the regular payment and says, well, how much are you going to have in the end? You choose this first equation because you want to know how much money you have in the end. If the problem gives you the amount that the person is trying to save and wants to know what the payment amount would need to be, well, if you want to know the regular payment amount, then you're going to use this equation where it's solved for the payment amount. And basically that's just summarized here, what you see in these highlighted statements there. And so let's look at example one. So you check your budget and you realize you're able to set aside $150 per month to save for your child's college. So right there, that looks like it's the R value, because that's the amount per month that you're able to save, or your regular deposit. So I'm just going to write down R equals 150. That's my regular payment. Your child will go to college in 10 years. So that would be the total amount of time. And just like with compound interest, you want to make sure time is always in years. never months. The account is a 3.4% interest rate. Again, just like compounding interest or the compound interest equation, the rate has to be a decimal. So you're going to take the 3.4%, drop the percentage sign, and move that decimal 2 spots to the left with a placeholder 0. So I'm going to write 0.034 for R. And the interest is compounded monthly. Okay, and notice that also coincides with the fact that you're making these regular deposits per month. And so N is equal to 12, since we're doing this monthly, 12 months per year. And then it says find the future value. So future value is A. So the A value is what I don't know. So since I don't know the A value, I'm going to choose this first equation here. And so I'm going to write down the equation, and then I'm going to plug in all of the values. And so since this equation is already written, I'm not going to write it down right here, but I would suggest every time you do these problems to write down the equation with all those variables and then plug in the numbers. And so in the equation on the top, we have R, so that's my regular payment, so 150. Now these brackets, they're just like parentheses. It's just we use brackets so that we can differentiate between this bracket and this parenthesis. But it functions just the same as a parenthesis. So in the calculator, you can put a parenthesis here. And then 1 plus, so my rate, 0.034, divided by my compounding period, 12, to the 12 times my time is 10 power minus 1, okay, divided by my rate, 0.034, divided by 12. And so I'm going to show you how to use a calculator to do this 2 ways. So if you have a TI 30 or 34, I want you to just press the N over D button, and we're going to type this in exactly how it looks, except for the fact that there isn't a bracket, so you're just going to use 2 parentheses. And then 1 plus, we use the fraction button again, 0.034, and then we come down below, 12. You make sure you use your right arrow to get out of the fraction, because that can be tricky and make quite a mess if you don't. And then the exponent key, so this caret key, it looks like an arrow, and you could do 12 times 10 up at the top. And then you want to use your right arrow to get out of the exponent position, minus 1. That's also a mistake that I see students make a lot, is it's easy to just stay up here in the exponent and put a minus 1. You want to make sure that the minus 1 is down below, just like it is in the problem. And then just like down here how I have written, I'm going to use instead of a bracket, I'll just use a parenthesis. And then I'm going to come down, and in the denominator I'm going to press the N over D button again so I can punch in 0.034, and then below that we have 12. And then now that I have everything in, I can just hit enter. And so I get a value of $21,402, and we always run around to cents, so 65 cents. And so that would represent the amount of money that I would have saved in the end if I put $150 a month for 10 years. And just for fun, if we were to take that $150, so take $150 times 12 months a year times 10 years, that alone would be $18,000. So this means that this person puts in $18,000, but they end up getting $21,402.65 in the end. So that just shows you just the beauty of compound interest. Because, just by putting that money in, making those regular payments, they were able to earn more. Okay, and so I want to just show you real quick how that would look if you either had a different calculator or just had a calculator where you didn't have that N over D button. So another option would be you do this one step at a time. So I'd work on the inside first. So I do 1 plus 0.034 divided by 12. Okay, so I do this is going to be first, and then I raise it to the exponent. So I'm going to keep that in my calculator, and I'm going to raise it to the 12 times 10 power, or you could do that ahead of time and just raise it to the 120th power. And then you have that, then you're going to minus 1, and then multiply by 150. Okay, that's going to be the numerator. So I've got 60.6408469. I write it all down, I don't round. And then I'm going to divide the denominator. So 0.034 divided by 12, and then I write that down. So 0.0028333333. And then I need to divide these two numbers. So 60.64084,679 divided by 0.002833333. So I should have 5 threes. There we go. Okay, and then I hit enter, and if you look, I've got the same answer as before. So 21,402.65. So that just hopefully can show you how you could do this with a different type of calculator. Okay, so let's jump into our next example. So in example 2, it's a little bit different. I'll even just jump ahead to the question. This one asks, how much do you need to deposit each month to meet your retirement goal? So when you're asked how much you want to deposit, that's what you're trying to find. You're going to want to use the equation that's solved for the R because you're trying to find the regular deposits. So we're going to go ahead and use that second formula. And so let's go ahead and read the problem. And as we read the problem, we're going to write down the important information. So you want to have $500,000 in your account. That's in the end. So at the very end, so that's your future value. So future value, we want to save $500,000 when you retire in 30 years. So T equals 30. Your retirement account earns 5.8%, so that's my rate. So I'm going to take 5.8%. I'm going to drop the percent sign and move that decimal 2 spots to the left, putting in a placeholder 0. So 0.058, and then annual interest. How much do you need to deposit each month to meet your retirement goal? So because the deposits are made each month, that tells you your N. So N equals 12, since we're making 12 deposits per year. And then how much do you need to deposit? That's my R value. We don't know what that is, so we're trying to find that. So I'm going to use the second equation. So I'm going to write R equals, and in the numerator we have A, so $500,000 times our rate over our compounding period 12 divided by, and just like in the last one, we've got these brackets. Remember, that's just like a parentheses. So bracket parentheses 1 plus our rate divided by 12 to the 12 times t power. So t is 30, so 12 times 30, and then minus 1. And then if you have this kind of calculator, a 34 or 30, TI 34 or 30, you can use the N over D button, and it makes entering pretty simple. I'm not going to say easy because it's easy to mess this up, so you still have to be careful. I'm going to press the N over D button here, 0.058, simpler than if you had a different calculator, let's say that. And then 12, and then remember, whenever you're in the fraction, you want to use the right arrow to get out of it, and then end the parenthesis. And then we're going to come down below by pressing the down arrow, and I'm going to do 2 parentheses, 1 plus the N over D button, 0.058 divided by 12. I'm pressing the right arrow to get out of that fraction. I'm going to end that parenthesis, which is right here, and then I'm going to raise that to, so exponent key, 12 times 30 power, and then remember to use the right arrow to get out of that exponent position, so that way when you put the minus 1, it's down below and not up top with that exponent. And then lastly, you're going to do an end parenthesis, which is just like this end bracket, and then hit enter. And so now we have our regular deposit, so $517, and we want to round to cents. Since the digit after our rounding digit is an 8, it tells us to bump that 9 up, so this is going to become 10 cents instead of 9 cents. So this means that this person would have to deposit $517.10 per month for 30 years in order to have $500,000 in their account. And just to show you in terms of the interest, if we take 517, 10 times 12, so 12 months a year, times 30 years, that money that they deposit alone is $186,156. But look at how much more they actually earn. They earn $500,000 because of that compound interest. So pretty powerful. And then just like before, if you wanted to do this step by step, you could. So you could just do the numerator. So 500,000 times 0.058 divided by 12. And you get, in the numerator, we get 2416.666667 divided by, and then in the denominator, I'm going to do the parentheses first. So I'm going to do 1 plus 0.058 divided by 12 raised to the 12 times 30 power, and then minus 1, and then I write that number down. I'm going to try not to round because it'll keep my answer more exact. And then I'm going to divide these two numbers. So 2416.666667 divided by 4.673512987. And I get the same amount of money that I got before. So don't worry if you don't have this kind of calculator, you can still do this with any type of calculator.